Hi, good evening, everyone. So, beta, today we are going to go ahead and take the next numerical. This is DSEM applications that I'm just discussing with you. And in this, there is this numerical that I want to really go ahead and take, right? Let us try to see what this question is saying. So, it says, First Welfare Theorem with external effect. Dekho dhyan se, try to read it out, beta. It says, consider two individuals with utility functions. So utility function of individual A is given to you as XA, YA. And utility function of individual B is given to you as XB, YB minus 0.5 XA. तो एक बहुत important चीज है, if you realize, try to see that utility function of individual A is only impacted by his consumption of good and X and good Y. Individual A सिर्फ अपनी consumption से affect हो रहा है. इंडिविजुअल ए को सिर्फ इससे फर्क पड़ रहा है कि वो गुड एक्स एंड गुड वाई का कितना कंजम्पशन कर रहा है. सो इंडिविजुअल ए इज इन अ वे altruistic. Altruistic means he is only affected by his own consumption, जो होना चाहिए, right? Now let us go ahead and let us try to think about individual B, right? So when I talk about individual B, sorry, he is not altruistic. Altruistic is a person who gets happiness above oneself, right? Above oneself. अगर मुझे मेरे से ऊपर किसी से खुशी मिलेगी, right? Then I am altruistic. He is selfish, right? I just said the reverse. So we are saying that he is selfish. मतलब individual A gets utility only from his own consumption. उसे सिर्फ अपनी खुद की consumption से utility मिलती है. Now try to go ahead and look into individual B. बेटा B की तरफ देखते हैं. Try to look into individual B. So when we talk about individual B in this case, individual B is getting utility from his own consumption, but यहाँ पे उल्टा है. He is negatively impacted from the utility of individual A. देखो, there is a negative sign here. So individual B is negatively impacted by the consumption from individual A. जब भी इंडिविजुअल ए का कंजम्पशन बढ़ेगा, इंडिविजुअल बी का यूटिलिटी कम होगा. तो इन अ वे वी कैन गो अहेड एंड वी कैन से दैट दिस इज अ केस ऑफ नेगेटिव externality. This is a case of negative externality. Why negative externality, beta? Because when the consumption by individual A is increasing, we can see that the utility of individual B is decreasing. So this is the example of negative externality. Okay. Now let me try to take further information into account, beta. So try to notice here that the endowment bundle of individual A, this is given to you as 15,5, and the endowment bundle of individual B, that is given to you as 10,15. So if I add the total amount of good X, या first good, it will give me 25. And if I add the total amount of the second good, it will give me 20. तो ये दोनों गुड्स के हमारे पास अलग अलग अमाउंट आ गए, 25 and 20. क्लियर? ठीक है बेटा. Now let's look into the various questions that can be asked from this part. So try to read this out. Try to look into the first part. What is it saying? Is individual A's utility affected by B's consumption? क्या A B से affect हो रहा है? Is A getting affected by B? No. A is not being affected by B. A is only getting affected from his consumption of good X and good Y. So A is not getting affected by B. A is only getting affected by his consumption of good X and good Y. So this is definitely incorrect. ये ठीक नहीं होगा कहना, right? Okay, beta. Now look into the second part. So this is saying, is individual B's utility affected by A's consumption? Yes. यहाँ पर B का utility A से impact हो रहा है. So if you see, there is a negative sign here. So as consumption by individual A of good X increases, utility of individual B decreases. जैसे जैसे individual A good X का consumption बढ़ाएगा, as individual A will increase the consumption of good X, the utility of individual B will decrease. वो गिर जाएगी. So this is the first part to it, beta. Now let us try to go ahead and try to look into the second part. So this says find the equilibrium allocation. Very simple question. How do you find equilibrium, beta? So we know that each consumer finds his equilibrium wherever he will achieve the tangency condition. And where is the tangency condition achieved, beta? Wherever his MRS will be equal to the price ratio, that is where we will be achieving the tangency condition. जहां पे भी MRS price ratio के equal होगा, we will go ahead and achieve the tangency condition there. So if I look about individual A's utility function is given to us as XA, YA. So what will be the MRS of individual A, beta? MRS can be given by MUX by MUY. So if I go ahead and I differentiate this with respect to X, so what will I get, beta? I will get YA. X ka differentiation will be 1. When you are differentiating with respect to X, Y is a constant. So ye ho gaya YA. And when you will be differentiating this with respect to Y, so X will be a constant and differentiation of Y will be 1. So you will get XA. So the MRS will come out as YA by XA. And you have to equate this to the price ratio, PX by PY. Okay? Acha. Because, beta, here you are given an endowment bundle. So what is the endowment bundle of individual A? The endowment bundle of individual A is given to us as 15 units of X and 5 units of Y. 15 units of X and 5 units of Y. तो क्या आप मुझे बता सकते हो what is going to be the income of individual A? Income can be given as 15 into PX plus 5 into PY. क्या हो जाएगा income? 15 into PX plus 5 into PY. So now we know that when we look at the budget line of individual A, the budget line can be written as PX into X plus PY into Y is equal to income of the consumer. ठीक है जी? But अच्छा, this is all for individual A, हाँ? But we know, क्या पता चला है हमें? We know from the tangency condition that YA into PY is equal to XA into PX. For individual A, ध्यान से समझना बात को बच्चे, YA into PY मतलब units of good Y consumed, कितने यूनिट गुड Y के वो कंज्यूम कर रहा है, into the price of good Y. तो यूनिट्स into प्राइस क्या दे देता है बच्चे? It will give us the expenditure on good Y. This will give me the expenditure on good Y. अच्छा, good X का आप देखते हैं हम जरा ध्यान से, तो PX is the price of good X. ठीक है, X are the units of good X, isn't it? So beta, price of good X into units of good X, what will this give me? This will give me the expenditure on good X. So this helps me understand that at the point of equilibrium, जहां पे हम equilibrium attain कर रहे हैं, the expenditure on good Y is equal to the expenditure on good X. Good Y and good X पे जो expenditure हो रहा है, that is the same. ठीक है, that is my tangency condition equilibrium. So if the expenditure on good Y and good X are same, so I can rewrite this thing as PX into X plus PX into X, because this PY into Y and PX into X equal at equilibrium. And the income of the consumer is this beta. So this can be written as 15px plus 5py. Clear? तो बेटा I can go ahead and say 2px into x will be equal to 15px plus 5py. ये मैं बोल सकती हूँ. So from here I will get that xa will be 15px plus 5py divided by 2px. So this will go ahead and give me 15 by 2 plus 5 by 2 py by px. This will give me 7.5 plus 2.5 py by px. तो बेटा the demand, ध्यान से listen to me very carefully, the demand of good x by individual A is this. For now, I have not considered any external effect. मैंने कोई external effect नहीं consider किया है. I haven't considered the fact that individual X, individual A is affecting the utility of individual B negatively. A जब अपना कंजम्पशन करता है गुड एक्स का, तो वो Y की यूटिलिटी को नेगेटिवली इंपैक्ट कर रहा है. फॉर नाउ आई हैव नॉट कंसिडर्ड दैट फैक्ट. इस फैक्ट को मैंने अभी के लिए कंसिडर नहीं किया है, एंड आई हैव जस्ट ट्राइड टू गो अहेड एंड फाइंड दिस इक्विलिब्रियम. क्लियर हो गई बात बेटा? ये इज दिस एब्सोल्युटली क्लियर टू एवरीवन? ठीक है, ओके. नाउ व्हाट वी विल डू ना बेटा, आई विल डू अ सिमिलर एनालिसिस फॉर इंडिविजुअल बी. जो हमने अभी पूरा इंडिविजुअल ए के लिए किया, हम अकॉर्डिंगली वी विल डू इट फॉर बी. धीरे धीरे चलेंगे. So now let me try to go ahead and find out the utility function of individual B. This is given to me as XB YB minus 0.5 XA. Beta, individual B will also try to go ahead and equate his MRS to the price ratio, right? So if I try to find out his MRS is going to be MU X by MU Y of individual B. So MU X will be how his utility changes when the consumption of good X changes. In his control, देखो, X is exogenous. This is not under his control. उसके कंट्रोल में नहीं है कि गुड X का कंजम्पशन इंडिविजुअल A कितना कर रहा है, right? Let's say XA represents the amount of smoking. तो it is not under my control ना how much smoking good of good X individual A will do. ये मेरे कंट्रोल में नहीं है कि A कितना स्मोकिंग कर रहा है. उससे I am getting affected negatively, but that is not under my control. मेरे कंट्रोल में क्या है कि how much of good X I will consume and how much of good Y I will consume. तो I will just find my MRS. My MRS will be MUX by MUY. So when I will be differentiating this with respect to good X, though this is differentiation, and here I will be differentiating this with respect to good Y. So when I will be differentiating this with respect to X, beta, I will get YB. यहाँ पे there is no XB, so minus 0. And with respect to Y, beta, I will be getting XB minus 0. So this will go ahead and give me YB by XB. This will give me YB by XB. And what will I go ahead and do, beta? I will equate this to the price ratio. So I have to equate MRS to PX by PY. So YB by XB is equal to PX by PY. So this is going to be YB PY is equal to XB PX. Clear? Acha. Now what we can do now, we can also find the income of individual B. So what is the endowment bundle of individual B, beta? The endowment bundle of individual B is 10, 15, right? So let me write down the endowment bundle of individual B. This is going to be 10, 15. So what will be his income? Endowment bundle है 10, 15. तो 10 units of good X है उसके पास, 15 units of good Y है, right? बेटा व्हाट कैन बी रिटन एज द बजट लाइन? बजट लाइन को हम कैसे लिख सकते हैं? हाउ कैन आई राइट द बजट लाइन? द बजट लाइन कैन बी रिटन एज px into x plus py into y is equal to income. I am doing it for individual B. But from the tangency condition, we have found out that px into x is equal to py into y. So I can just go ahead and write here px into x plus px into x is equal to what will be his income beta? 10 px plus 15 py. Clear? Acha. From here, I will get 2 px into x is equal to 10 px plus 15 py. So I will get xb as 10 px plus 15 py divided by 2 px. So this will give me 5 px plus 7.5 py by px. This will be xb. क्लियर बेटा? अब बहुत इंपॉर्टेंट चीज है, बहुत इंपॉर्टेंट टास्क है. आई हैव फाउंड आउट दैट माई एक्स ए, देखो ध्यान से, आई फाउंड आउट, यहां पे हम एक अलग लिख लेते हैं. आई फाउंड आउट दैट माई एक्स ए वॉज 7.5 प्लस 2.5 पी वाई बाय पी एक्स. ये डिमांड ऑफ गुड एक्स बाय इंडिविजुअल ए है. एंड आई फाउंड आउट दैट माई एक्स बी इज 5 प्लस 7.5 py by px. ये डिमांड ऑफ गुड x, दिस इज डिमांड ऑफ गुड x बाय इंडिविजुअल a and this is demand of good x by individual b. ठीक है बेटा? when will your market clear? मार्केट कब क्लियर करता है? मार्केट क्लियर्स when the demand of good x should be equal to supply of good x. And how many units we had in the supply beta? कितने units का supply था good x के? 25 units का. We had the supply of 25 units of good x. तो यहाँ पर जो हमने demand function लिखा है ना, it must be, so demand function को if I just add it out, तो I will get demand of good x should be equal to supply. Supply is 25 units beta. So this is going to be 12.5 plus 10 py by px. So I will get 12.5 plus 10 py by px is equal to 25. So let's solve this beta. 10 py by px is equal to 25 minus 12.5. So py by px will be 12.5 by 10, 1.25. So your price ratio py by px will come out as 1.25. That means 5 by 4. That means 5 by 4. Clear हुई ये बात बेटा? तो I have found out the optimal price ratio in this case. हमारा जो optimal price ratio है, we have been able to go ahead and find that out. Right? Clear? Okay, beta. So once we find out the optimal price ratio py by px, now you can find the optimal bundle also beta. तो py by px आ गया है हमारे पास 1.25. जस्ट पुट इट हियर, आपको मिल जाएगा 7.5 प्लस 2.5 इंटू 1.25, है ना? इसी तरीके से आप xb में भी डाल देना. तो xb ये था, तो यू कैन जस्ट से px was cancelled beta. तो यू कैन जस्ट से 5 प्लस 7.5 इंटू 1.25 xb आ जाएगा. राइट? और हमें ये भी पता है कि px इंटू x वॉज इक्वल टू py इंटू y. तो जो y का कंजम्पशन हो जाएगा दैट वुड बी px बाय py इंटू x, एंड ये हो जाएगा 1 बाय 1.25, क्योंकि py बाय px इज 1.25. x का वैल्यू यहां से आपके पास आ ही जाएगा. जस्ट प्लग दैट वैल्यू, यू विल बी एबल टू गेट y. तो यू विल बी एबल टू गेट बोथ x एंड y. Am I making sense? तो you will be able to get both x and y, और यहीं से हमें ये अपना डिमांड भी मिल जाएगा. We will be able to get these demand bundles. Okay beta, now let me go take you through the next part. एक बारी part number C देखते हैं what this part is saying. So this part is going ahead and it is saying that show that equilibrium allocation is not socially efficient. ध्यान से देखो, you need to show that equilibrium allocation is not socially efficient. So when will this allocation not be socially efficient? Listen to me. If holding the utility of individual B constant, I am able to increase the utility of individual A, then it will not be efficient. Or if holding the utility of individual A constant, I am able to increase the utility of individual B, then the initial allocation is not socially efficient. इसका एक एग्जाम्पल पहले मैं आपको बड़े आसान लैंग्वेज में समझाती हूँ, देन वी विल कम डाउन टू दिस क्वेश्चन. सो ट्राई टू सी बेटा. देखो, इफ आई जस्ट गो बैक टू माय यूटिलिटी फंक्शन, थोड़ा सा समझने की कोशिश करते हैं. लेट्स से यूटिलिटी फंक्शन ऑफ इंडिविजुअल ए इज एक्स ए वाई ए. यूटिलिटी फंक्शन ऑफ इंडिविजुअल बी है एक्स बी वाई बी माइनस 0.5 एक्स ए. सपोज बेटा आई एम टेलिंग यू कि यूटिलिटी ऑफ इंडिविजुअल ए अभी ही इज कंज्यूमिंग 5 यूनिट्स ऑफ बोथ गुड्स, तो यहाँ पे 25 यूटिलिटी है. कुछ और ले लेते हैं. लेट मी टेक सम अदर नंबर. इट्स अ मल्टीपल बनाना आसान रहेगा. सो सपोज हिज यूटिलिटी इज 50. अभी इंडिविजुअल ए का यूटिलिटी 50 है सपोज, और इंडिविजुअल बी ना ही इज ऑल्सो कंज्यूमिंग दीज टू गुड्स ओनली. तो यहाँ पे भी 10 है और यहाँ पे भी 10 है, माइनस 0.5. I will take this 10 also. Let me take this 10. Minus 0.5 into 10. So this is going to be 100 minus 5, 95. एक एग्जाम्पल ले रहे हैं. तो करेंटली व्हाट आई एम सेइंग ना कि यूटिलिटी ऑफ इंडिविजुअल ए 100 है और यूटिलिटी ऑफ इंडिविजुअल बी 95 आ रहा है. राइट, यूटिलिटी ऑफ इंडिविजुअल बी इज कमिंग एज 95. Now my question is there any way in which I can increase the utility of individual B holding the utility of individual A constant? क्या कोई तरीका है कि हम A की यूटिलिटी को 100 पे रखते हुए B की यूटिलिटी बढ़ा पाए? Yes, there is a way. What's the way बेटा? Because I see that individual B gets negative utility when A increases consumption of good X. जब जब ए एक्स का कंजम्पशन बढ़ाता है, बी का यूटिलिटी कम हो जाता है. सो व्हाट कैन वी डू? वी कैन गो अहेड एंड वी कैन लोअर द कंजम्पशन ऑफ गुड एक्स, इंक्रीज द कंजम्पशन ऑफ गुड वाई, तो हिज यूटिलिटी विल रिमेन अनचेंज्ड. एंड द मोमेंट वी विल गो अहेड एंड वी विल लोअर द कंजम्पशन ऑफ गुड एक्स, तो यहाँ पे बेटा आई just have 1 unit, so this will be 0.5. So when this will be 0.5, this will be 99.5. समझ रहे हो? तो I am able to increase the utility of individual B holding utility of A constant by lowering the consumption of good X. That means initial bundle was not Pareto efficient, right? और भी हो सकता है, even this is not Pareto efficient. I can further lower his consumption of good X and further increase his utility. Am I making sense? तो वो यहाँ पे हम समझा रहे हैं that if there is a way, okay, so this is what we are trying to explain here, that if there is a way in which I can go ahead and I can hold the utility of individual B constant. मैंने B की utility को constant रखा, and by holding the utility of B constant, I am able to increase the utility of A. Hold B constant, increase A, or hold A constant, increase B, then the initial combination is not Pareto efficient. ठीक है? तो अब हम यहाँ पे क्या कर रहे हैं, हम इसी पेरेटो एफिशिएंसी का वी आर ट्राइंग टू यूज द फॉर्मूला ऑफ दैट तो here what I am saying ना, I am saying I want to find out, मुझे ये निकालना है that where can I maximize the utility of individual A. मैं individual A के utility को कहाँ पे maximize कर सकती हूँ, holding the utility of B constant and ensuring that the market also clears. I need to ensure that the market clears. And when will the market clear, beta? When the total demand of good X will be only up to 25 units, because total endowment was 25 and total demand of good Y does not exceed 20 units. Am I clear with this part? ये बात clear हुई पूरा what I am aiming to do, what my aim is. Okay, so now all that you are left up to do is to go ahead and to apply Lagrange. हमें यहाँ पर एक Lagrange लगाने का जरूरत है. So I have just applied Lagrange. I have tried to maximize the utility of individual A following these three conditions. So plus lambda condition number 1, plus mu condition number 2, plus say some mu 2 condition number 3. ठीक है. And I am trying to go ahead and find the maxima condition. मैं यहाँ पे I'm trying to maximize the Lagrangian function. तो बेटा how will I maximize this Lagrangian function? What will I do? So just focus here. I am going to go ahead and differentiate this Lagrangian function with respect to XA. मैंने इसको differentiate किया with respect to XA. I am differentiating this Lagrangian function with respect to XA. तो जब हमने XA के comparison में इसको differentiate किया, I will get यहाँ से differentiation आ जाएगा YA बेटा. There is यहाँ से differentiation आ जाएगा -0.5 बचे. From here I will get the differentiation as plus mu1 and equal to 0. Then I will differentiate this with respect to XB. So here I will get here I have XB, so lambda YB, right? And then I have XB here plus mu1 into -1 equal to 0. Then I will differentiate this with respect to YA. So when I am differentiating this with respect to YA, here is YA, so I will get XA, right? And plus lambda, no lambda will come. I see YA only here. So plus mu2 into -1 equal to 0. And when I will be differentiating this with respect to YB, so I will go ahead and I will get, I can see YB here and I can see YB here. So I will get lambda into XB. And then I can see YB here na beta. तो प्लस mu2 into -1 equal to 0. बहुत इजीली समझ में आ जाएगा. 2 मिनट दे दो. Just give me 2 minutes. You will understand what I am doing. देखो मैंने 4 कंडीशंस निकाला. बहुत सेम है जैसे हम यूटिलिटी फंक्शन का निकालते हैं. हमने उसको XA के कंपैरिजन में डिफरेंशिएट किया, XB के कंपैरिजन में, YA के कंपैरिजन में, YB के कंपैरिजन में. एक और तरीका भी है टू सॉल्व दिस क्वेश्चन, क्योंकि the question is asking to find out the socially optimal level. What you could have gone ahead and done is you could have maximized the total utility of the society. आप वेलफेयर यूटिलिटी ऑफ द सोसाइटी को भी मैक्सिमाइज कर सकते थे और वहां से आपको एग्जैक्टली सेम कंडीशन ही मिलती है जो यहां से मिल रही है. तो आई विल शो यू दैट ऑल्सो. ध्यान से सीखनी है इस चीज को बच्चे. तो व्हेन आई एम डिफरेंशिएटिंग दिस विद रिस्पेक्ट टू XA, जब हमने इसको XA के कंपैरिजन में डिफरेंशिएट किया, लेट मी सॉल्व दिस. आई विल गेट YA is equal to lambda into 0.5, यहाँ पे into -1 है ना, तो I will get plus mu1. When I have differentiated this with respect to YA, so I will get XA is equal to mu2. When I am differentiating, this is mu1 with respect to YA. अच्छा mu2 है, correct, mu2. When I am differentiating this with respect to XB, I will get lambda YB is equal to mu1. And when I will differentiate this with respect to yb, so I will get lambda xb is equal to mu2. Lambda xb is equal to mu2. ठीक है, इज दिस क्लियर? तो अब यहां पर एक बहुत एसेंशियल चीज ये आती है बच्चे कि एवरीथिंग लुक्स वेरी सिमिलर टू व्हाट वी हैड डन द अर्लियर टाइम, बट द ओनली थिंग दैट चेंजेस इज दिस एक्स्ट्रा कंपोनेंट. सिर्फ ये एक कंपोनेंट एक्स्ट्रा कंपोनेंट आ रहा है. हाउ डू आई नो दैट दिस इज एन एक्स्ट्रा कंपोनेंट? बिकॉज इफ आई गो अहेड, सपोज मैं इनको ना डिवाइड कर देती हूँ. If I divide this equation with this equation, so I will get ya by xa is equal to lambda into 0.5 plus mu1 by mu2. Right? And if I just divide these two equations, beta, I will get yb by xb is equal to mu1 by mu2. ठीक है? अच्छा, एक बात बताओ. When we were going ahead and when we were solving individually, जब हम individually utility functions को maximize कर रहे थे, तो utility function of individual A क्या था बेटा? x से y है. utility function of individual B क्या था बच्चे? xb yb minus 0.5 x से. तो when we were individually maximizing them, तो यहां से what is the MRS we had got? MRS आया था YA by XA, और यहां से जब हमने इसका MRS निकाला था we had got YB by XB. एंड वी नो कि दोनों ही इंडिविजुअल्स अपने एमआरएस को प्राइस रेशियो से इक्वेट करते हैं टू px by py. दैट्स द टेंडेंसी कंडीशन. तो इफ आई वुड हैव कंबाइंड दीज टू टुगेदर, बिकॉज दिस इज आल्सो इक्वल टू px by py और ये भी px by py के इक्वल है, सो आई वुड हैव गॉट कि ya by xa इज इक्वल टू yb by xb. ये कंडीशन हमारी आ रही थी. ठीक है, ये कंडीशन है व्हेन ईच इंडिविजुअल maximizes their individual utility. अगर हर इंडिविजुअल अपनी इंडिविजुअल यूटिलिटी मैक्सिमाइज करेगा, सो आई विल गेट ya by xa इज इक्वल टू yb by xb. बट अगर हमें सोसाइटी की यूटिलिटी को मैक्सिमाइज करना है, सो नाउ नोटिस दैट बेटा आई एम गेटिंग दिस एज ya by xa. अगर मैं इसको थोड़ा ओपन करूं, आई विल गेट लैम्डा इंटू 0.5 by mu2 प्लस mu1 by mu2, है ना? एंड mu1 by mu2 इज इक्वल टू xb by yb by xb. तो mu1 by mu2 की जगह पे आई कैन राइट yb by xb. तो द सोसाइटी इक्विलिब्रियम, अगर हमें सोसाइटी को इक्विलिब्रियम पे लेके आना है, इफ आई वांट टू मैक्सिमाइज द वेलफेयर, हाँ, एक के मैक्सिमाइज करे वेलफेयर, होल्डिंग द अदर वेलफेयर कांस्टेंट. अगर हम एफिशिएंसी की बात करें, तो फॉर एफिशिएंसी ya by xa is not equal to yb by xb. rather I have an extra component here. मेरे पास ये एक एक्स्ट्रा कंपोनेंट आ रहा है, एंड efficiency condition is coming out to be this. समझे? So when individuals are maximizing their utility, जब हर इंसान सिर्फ अपने बारे में सोच के अपनी यूटिलिटी को मैक्सिमाइज करता है, we get ya by xa is equal to yb by xb. बट अगर हम सोसाइटी पॉइंट ऑफ व्यू से देखें एंड वी कंसिडर दैट एक्सटर्नैलिटी इनटू अकाउंट, तो हमारा एफिशिएंसी कंडीशन ये आता है वेयर दिस एक्स्ट्रा कंपोनेंट इज एडेड. So because the two conditions are not the same, we can say that society equilibrium and individual utility maximization don't give the same result. और वही चीज यहाँ पे इन्होंने लिखी हुई है. This is exactly what they have written here. That the two things are not exactly the same, because from here, यहाँ से जो हमें condition मिल रही है, that condition is very very different. वो condition same नहीं है जो condition हमें लोग जब सिर्फ अपना सोचते हैं तब मिलती है. बेटा, इफ यू फाइंड दिस डिफिकल्ट, अगर आपको लगता है कि दिस इज नॉट मेकिंग सेंस, तो इसकी जगह पे आप एग्जाम में ऐसा कुछ भी कर सकते थे, दैट यू कैन क्रिएट अ सोसाइटी वेलफेयर फंक्शन. और वो सोसाइटी वेलफेयर फंक्शन हो जाएगा यूटिलिटी ऑफ ए प्लस बी. तो यूटिलिटी ऑफ ए हो जाएगा एक्स से वाई ए, यूटिलिटी ऑफ बी विल बी एक्स बी वाई बी माइनस 0.5 एक्स से, और ये हमारा टोटल वेलफेयर हो गया. And you can try to maximize this welfare. So when I will be differentiating this with respect to XA, I will get YA minus 0.5. When I will be differentiating this with respect to XB, I will get YB. When I will be differentiating this welfare function with respect to YA, I will get XA. And when I will be differentiating this with respect to YB, I will get XB. ठीक है, तो अब अगर हम इस बेसिस पे और if on this basis I find out the MRS of individual A, तो MRS of individual A beta, that will come as MUX by MUY, and this will be YA minus 0.5 by XA. And if I find out the MRS of individual B, it will be YB by XB. दोनों ही इंडिविजुअल अपने एमआरएस को प्राइस रेशियो से इक्वेट करते हैं एट इक्विलिब्रियम. MRS is equal to PX by PY, and since they feel the same price, they equate it to the same price ratio. So from here, बच्चे, जो the condition that we get, it will be YA minus 0.5 by XA is equal to YB by XB. So this is the society welfare maximization condition. और when individuals were maximizing their utility, तो क्या condition आ रहा था? YA by XA equal to YB by XB. और ये दोनों condition same तो नहीं है ना? Here in the numerator, I have to subtract something. So since these two conditions are not the same, we can say that society equilibrium and where individuals are maximizing, they are different. और automatically सोचो ना, that whenever negative externality is involved, you always go ahead and you have a different social equilibrium. जो society का equilibrium होता है और जो individual का utility maximization होता है, that take place at different places, right? Okay, beta. Now let's go to the next part. So it says, does the first welfare theorem hold? Interpret your result. No, beta, they don't hold true. For first welfare theorem to hold true, you need perfect competition. You need no externality. You need no asymmetric information. You need no imperfect competition. So first welfare theorem will only hold true when all of this is satisfied. But under this case, अच्छा, you need no externality लिख दिया ना, हाँ. But under this case, since this is the case of negative externality, तो first welfare theorem does not hold true. First welfare theorem does not hold true. Okay, beta. Okay, beta. So this was an excellent question from the point of view of the exam, and I really hope that you understand this question very well. Thank you, beta.